So next, we're going to talk about torque. Torque is a measure of force that can cause an object to rotate around an axis. So torque is a force in a rotational direction. In manufacturing quality, torque usually refers to static torque as opposed to dynamic torque. We're talking about torquing down bolts and fasteners, for instance. So we have a tau, Greek letter tau, equals F times R. Torque equals force times radius. So imagine that you have a lug wrench here that is 0.4 millimeters, and you're using it to tighten a lug nut on the wheel of your automobile, and you're applying an upward force of 250 newtons. Well, we can calculate the torque we're applying to that lug nut by using our formula over here. So torque equals 250 newtons times 0.4 meters, or 100 newton meters. So that's how you calculate torque. For those of you who aren't familiar with newtons, I have a little conversion chart here below the tire. 1 newton equals 0.10197 kilograms, a little over a tenth of a kilogram. 1 kilogram equals 9.81 newtons. That's a measure of force. So then, of course, we have so-called torque wrenches. These are tools that measure torque. This is a beam-style torque wrench. It has a socket head of some kind over here, and let's say you're tightening a bolt. You tighten. This beam deflects, and you're able to read a torque value on this. So this is a very precisely made beam, and you can read it on this gauge right here. There's some digital ones. This electronic torque wrench. This uses a different mechanical mechanism, a click torque wrench. So you set the torque with the handle. This handle dials. You set it to a certain level of torque, and then you tighten, and then eventually it just starts clicking. So in other words, it doesn't tighten anymore. So a wide range of torque wrenches. Protractors, commonly used to measure angles. A lot of children use these in elementary school or geometry class, things like that. Different, this is probably a plastic, more like geometry class protractor. This is for measuring maybe in a layout or a lab or something like that. So here is how a protractor is used. We have this angle over here. So imagine two different angles. So a straight line would be 180 degrees. Well, ours is an angle, so we have an angle A on the inside, angle B over here, and reading angle A equals 129. You can see right there, just short of 130. Angle B, you read on the outside, that's 51. So knowing how to read these is pretty important. Knowing there's two scales, there's the outside and the inside, so just a little thought before you read the angle, that'll help. Angle measurement. So angles can be set in machining or machining applications using angle blocks. So kind of like the torque wrenches, right? Sometimes you're trying to apply a torque. Sometimes you're trying to measure a torque, right? So sometimes you're trying to measure an angle. Sometimes you're trying to set an angle. So this would be an example of a tool that helps you set an angle. Maybe you need to set up a block of aluminum in a vertical mill, and you want a particular angle on the face. You want to face that block of aluminum and create a certain angle. Well, you can set that angle using this rotating angle block right here. There's other types of angle blocks. These are static angle blocks. So these are more like gauge blocks, and each one of these will have an angle. It'll be laser etched onto the face of it, and you can see down here. Again, if you want to, this could be brass or something. Anyway, if you want to have a particular angle on this face, well, this angle will end up matching this angle. So those are common for machinists. Here's one of my favorite tools, actually. I love this thing. It's called a sine bar. This is used for setting angles as well. I find it interesting for a couple reasons. So sine is used in combination with gauge blocks to very precisely set the angle of a part. So the sine, S-I-N-E, is a trigonometric function. You'll learn that in trigonometry. But we'll do a little bit of trigonometry, but it won't be that hard. So this sine bar, these are made to have a very precise length, 100, 200, 300, 400 millimeters from center to center. So it has a very precisely manufactured and known length. Well, the other piece here is the height. And the height you generate using gauge blocks. And again, if you remember that gauge block set, boy, you could set almost any size you want down to the 0.01 millimeters. So you could, very precise height you can generate here using gauge blocks. Well, then what that results in is a particular angle we'll call theta, and it's right, I should have lowered the arrow just a little bit more. So theta is the angle between this datum, this flat surface, and this surface right here. So then you use a little formula. Sine of theta equals h over L, height over length. So the length, again, it's fixed. It's part of the sine bar. It's printed on the side, 200 millimeters long. So you know what that L is known, right? H is known because, well, you're gonna make it knowable through using the gauge blocks, right? So then that generates a particular angle. This is what you're trying to get. You get theta by setting h using a sine bar of a known length. Let's look at our little problem here. Find the height of a gauge block. What height of a gauge block do we need to achieve a 27.5 degree angle with the 200 millimeter sine bar? Well, we have our formula right here, right? Sine of theta equals h divided by L. So the question is sine of 27.5 degrees equals h, that's our gauge block, divided by 200 millimeters. So the question is, how many gauge blocks, what size gauge blocks do I need underneath my sine bar? So I just do a little, that's just a little algebra. And we haven't talked about trigonometry, but there's a sine, S-I-N button on your scientific calculator. You just do the math, 200 times 27.5 sine equals 92.35 millimeters. So if you get 92.35 millimeters stack of gauge blocks and put them underneath the 200 millimeter sine bar, you will generate a 27.5 degree angle. So it's beautiful because its versatility is in that you can set this height for almost anything that you want.